This video is an introduction to osmolarity. Osmolarity is a concentration unit that can be used for solutions. Typically we talk about solution concentration in molarity in chemistry in moles per liter, but it is most commonly encountered osmolarity in the medical field. So again, we like to say molarity is moles per liter in chemistry. And sometimes you just abbreviate that MOL or MOLES, but we like moles per liter. But the medical field likes osmolarity or osmoles, and that's the total moles of particles divided by liters of solution. So it's really similar. It's just all the moles of dissolved ions or particles. So this total moles is the important part. This is because medical solutions often have more than one solute present. Human plasma is one such solution. The dissolved particles might include cations, anions, covalent compounds such as glucose, proteins, etc. So in a healthy human, the total moles of all these dissolved particles per liter of plasma is approximately 0.3 moles. This means that the osmolarity of normal human plasma is 0.3 moles per liter, or 0.3 osmoles, or osmolarity. Okay, so 0.3 is normal. Any solution with this same osmolarity, or close enough to it, is called isotonic. So if you're close to 0.3, that's isotonic. If a solution has a concentration higher than that, it's called hypertonic, hyper for extra. And a lower concentration is called hypotonic. So hypertonic is something that's above 0.4 osmolarity, and then hypotonic is something less than 0.2 osmol. So between 0.2 and 0.4 is considered isotonic or normal. Hyper, having extra, is 0.4 or greater. Hypo, or having less, is less than 0.2. Okay, so all solutions that come into contact with a semi-permeable membrane, such as a cell membrane, need to be isotonic with the solution inside the cell or problems arise. In the case of the human body, normal physiological concentration in all cells is about 0.3 osmoles. We will see in class what happens specifically if a cell is placed in contact with hypotonic or hypertonic solution. So how is osmolarity calculated? Osmolarity equals molarity times the number of particles that have been dissolved. Remember, the number of particles is going to be 1 for non-electrolytes, think sugar or glucose. It's going to be 2 or more for electrolytes because you're going to have 1 for each ion. So check out some examples. If we've got 0.1 molar C6H12O6, that's just going to have 1 particle because it's a non-electrolyte. So to get osmolarity, we just take 0.1 times 1 and we get 0.1 for osmolarity. What about for calcium chloride? We have 0.1 molar calcium chloride, multiply that by a calcium ion and 2 chlorine ions is 3 total ions, 1 calcium, 2 chlorine. So 0.1 times 3 is 0.3. How about magnesium phosphate? Remember how that had 5 particles? It had 3 magnesium ions and 2 phosphate ions, 5 total ions. 0.1 times 5 is 0.5 for its osmolarity. So again, any covalent compound, any non-electrolyte, any covalent other than an acid or a base gives a 1. And, then for those electrolytes, we have to calculate how many particles they dissolve into when they dissolve in solution. So that's just a brief introduction to osmolarity.